Hello, this is Nikhilesh. As part of machine learning project, I'm here to present you all my project title, A Quality Prediction Using Machine Learning. Air pollution is a pressing global issue impacting health and the environment. It's a silent killer contributing to millions of premature deaths worldwide each year, exacerbating respiratory and serious cardiovascular diseases. Beyond human health, air pollution damages ecosystem, reduces crop yields, and significantly contributing to climate change. Air quality prediction is therefore vital for public health advisories, enabling individuals to take preventive measures and for informing crucial policy decisions to mitigate pollution sources. My project improves existing research paper titled Prediction of Air Pollution using support vector machine, which was published on November 2024. The goal is to predict air quality index using machine learning using various ensembling models on dataset consisting of pollutants. Air pollution largely depends by combustion of fossil fuels, rampant vehicle emissions, and unbridled industrial activities constitutes one of the most pressing global environmental health crises of our time. It manifests as a silent killer, leading to a surge in respiratory diseases, cardiovascular diseases, and premature deaths, while simultaneously degrading our ecosystem. Accurately predicting a quality is then inherently complex. It requires untangling intricate interplay of fine particle matter that is below 2.5 millimeter and coarse particle matter which is PM10 that is below 10 millimeter and nitrogen oxide, carbon monoxide and various harmful gases, all further complicated by dynamic meteorological conditions like wind patterns, temperature inversions, and humidity. Traditionally, reactive monitoring systems often provide historical data rather than real-time insights, providing sufficient for proactive management. This gap underscores urgent need for advanced predictive models such models are not merely academic exercises, they are crucial tools for enabling timely public health advisories, triggering preventive measures, and therefore policy decisions and therefore helping policy decisions, thereby mitigating the devastating human and environmental costs. Dataset that are used to modeling is sourced from Kaggle, which contains high-quality measurements from various Indian cities. It includes features like PM2.5, PM10, nitric oxide, nitrogen dioxide, nitrogen oxides, ammonia, carbon monoxide, sulfur dioxide, and ozone, where at ground level ozone is harmful pollutant formed when nitrogen oxides and volatile organic compounds react in presence of sunlight. It's a major component of smog and causes serious respiratory issues. Whereas in stratosphere, whereas it is found higher in stratosphere and is beneficial as it protects us from UV radiation, along with for, uh, further features like daytime city. With missing values, further analysis along statistic method of SEMA approach, converting data into no missing values, and exploratory data analysis with histograms, block plots, and which help understand data distributions and identify outliers. Furthermore, ready to be trained for models. Project involves several steps. First, data is pre-processed, ensuring no missing values, and it also includes feature engineering such as extracting temporal data feature from date, such as year, month, day of week from date column. Outliers were handled using two strategies. by removing outliers and capping them, whereas removing outliers where we completely remove the extreme outliers. For capping outliers, we replace extreme outliers with maximum and minimum values respectively. Model is Models tested are includes linear regression, decision trees, uh, support vector regression, random forest, XGBoost, MLP regressor, and a stacked model. Furthermore, let's look into the code that have implemented. In the beginning of this Python notebook, I have first imported all the necessary libraries such as pandas for data framing, NumPy for numerical Python, and matplotlib, cbon for various plotting histograms, boxplots, heat maps, correlation matrices, pair plots, and charts, and furthermore visualizations. And Skyline for standard scalars. Here I have imported a train test kit for training and testing the models. And for Sky, I also imported a standard scalar. And furthermore, models such as linear regression, decision tree regressor, SVR regressor, which is support vector regressor, random forest regressor, and furthermore, XGBoost regressor for gradient boosting, and also MLP regressor. And from Skyline, and also imported various evaluation metrics such as R square, mean absolute error, mean square error. And here have imported Kaggle Hub, which is necessary for getting data set from Kaggle site. Here I got data set of the quality of India. Uh, Before this part, I have actually cleaned the data set using SEMA approach, which is sampling the data set, exploring data set, like counting missing values and distribution of shapes, and further modifying it, whereas I have dropped the columns which has no values greater than 50 or 70, 50 or 30%, and imputed columns with median, mode, and address outliers by removing and address outliers by using two strategies by removal and capping the assets formatted, and will compare multiple regressive pipelines to predict AQI to further predict AQI and further reassessing models, and furthermore cleaning the data. This is the data now at present I have. This is the statistical summary of the data, and we can see here it has zero missing values. Uh, yeah, okay. As I said, after analyzing various data, uh, furthermore, using histograms, here we could see many histograms, which shows PM 2.5 against AQS scores, and box plots for looking for outliers. Here we can see many outliers, and furthermore evaluating data sets. Here we have generated a correlation matrix which has a good correlation matrix, and using C1, I have created a pair plot chart, and I did some feature engineering, such as adding more columns from date columns, such as year, month, day, and day of the week. Furthermore, adding data to dataset, which increases modeling. And here we can see 17 features, 17 columns, which is of say, which is of no, and everything is converted, even categorical data is converted into numerical data, except equivalent, which we will be doing further. And uh, here I have said df cat df for outlier handling. Here we have by using set score, we have we have strategically converted. Here for outlier handling, we have used set score, that is by using mean, and we have subcategorized into two parts, that is capping the dataset and removing the dataset. Where in capping the dataset, where missing outliers with greater than 30% is being removed, and for missing the and for cap and for outlier handling, we have done two ways, which is removing the outliers that has extreme values and capping the outliers that have extreme values. And capping the outliers, we have capped outlier which has extreme outliers to maximum and minimum values respectively using z-score method of mean values. And here we can see feature importance. With PM 2.5 PM, then ozone has more feature importance than the other. Here describes our data set. First have created sequence. String here data set is being described of every column. Here predicting variable air quality index of test set to test test set to. Here I have defined a function called train evaluate that takes inputs, data frame and features with tagger variables as AQI, that is air quality index, and test size as uh, zero point 0.2, which is 20%, and sequence length of 7. Here we have splitted the data accordingly and scale the features and transform it, that are linear regression decision tree SVR with kernel is equal to linear as implemented by the previous research paper, and is equal to 1 random forest with estimators of 100 XGBoost MLP regressor. Here I had defined the results with an array which stores the results of these models, and further down here over here I had defined a stacked model and appended it to results, which also calculates all the evaluation metrics such as R square, uh, MAE, and RMSE, outlier, cap, And passing features, we have generated uh, different models such as linear regression, decision tree, SVR, random forest, XGBoost, ML regressor with respect to R square metric. And for data set that is removed outliers, we can see similar charts is being displayed, such as linear regression, decision tree, SVR, random forest, XGBoost, ML regressor, which looks more better accuracy than other models. Models with respective evaluation metric scores accordingly of results with outliers removed and results with outliers capped, where results with outliers capped has better accuracy than outliers removing, reducing loss of data set. And we have plotted graph of uh, outlier handling comparison with respect to removed and capped. We can see here outlier capped has performed better than outlier removed. And furthermore, here we have generated a bar graph of comparing various models, accuracy of various models. Now we can see chart generated here where models were evaluated using R square metric. And over here we can see capped outliers has outperformed and regressors such as stacked model, MLP regressor, XGBoost, random forest has performed slightly better than traditional models such as linear regression, decision tree, SPR. And I have coded here to print the best model, and we can see here the best model with outlier removed is MLP regressor, that is with R square endpoint 1, and best model with outlier cap is same MLP regressor with R square uh, 0.92. Overall, the best model is MLP regressor. The best performing model is NLP regressor. NLP regressor achieved highest R-square score of 0.92 with outperformed SVR data, SVR model and other models. And there is a stacked model which has similar R-square and evaluation metrics such as NLP regressor. Its strength lies in capturing complex and nonlinear relationships within high-dimensionality data and interdependent data. Interpreting results. PM2.5, PM10, which is particles within 2.5 and 10 millimeter, and gases like nitrogen dioxide are key predictors for predicting AQI. That is, it has high feature importance. And then also by adding temporal features which contributed to dataset. Capping outliers had also improved performance by preserving useful information. NLP outperformed support vector machine contrary to our referred research paper. And hence, neural networks, specifically NLP regressor, are highly effective for AQI prediction. Capping outliers significantly improve model performance. Future work includes incorporating meteorological data, exploring time series use, and also we can use models like ARIMA, LSTM, and more ERNN and more neural networks for training the models, and which might yield accuracy results of 95 to 99%, and hence further contributing to efficient accuracy of prediction. Thank you.